All right, so today is going to be another lesson with the vertex form. There's one little piece that we are going to add in today, and that's a little bit comparing the vertex form to the standard form. So there are basically three different forms of quadratic equations as far as graphing is concerned. So you have something called standard form. So you probably should jot these up at the top of your notes. And standard form would be y equals ax squared plus bx plus c. So basically all of the parentheses are distributed away and there's just addition and subtraction signs in between the different terms, and they're going to go in descending order, starting with the x squared term, followed by the x, followed by the constant. Then we have vertex form, which we're working on this week. And that is y equals a times x minus h squared plus k. And that form is, it's a little bit factored from this. It's not totally the intercept form was the other one we worked with last week. Intercept or factored form. And that is a times x minus p and x minus q. Okay, so first we had worked with the intercept slash factored form, and that was because we had just done and completed the chapter on factoring. And we realized that these two factors, if we set them equal to 0, those were the x-intercepts of the graph, and then we could average out those two numbers and find the vertex and go from there. Now we've been working on this vertex form, right? So we know that the h and the k is the vertex. But then we're going to move on to standard form when we're done with vertex form, and that's when all the parentheses are gone. Now, standard form is the hardest form to graph. It's not as easy as the two that we've just finished. But a lot of times equations are given to you in that form, and then we'll learn how to go back from standard form into one of these others to make it easier to graph. But right now, I just wanted to make sure you could recognize the different forms. So we're just looking at numbers 1 through 4 here. And we're just going to say which one it is. So number 1, you can see there's no parentheses anywhere there. It's just x squared minus 2x minus 35. So this would be an example of a quadratic equation that is in standard form. And that's it. We just want to make sure we can tell the difference. Number 2, when you have the parenthesis with the square on it, that's like call it square of a binomial. And then you can have a number in front of the parentheses, and you also can have something adding or subtracting to the back. So that would be an example of the vertex form that we've been working with here for a couple days. Number 3 as well would be vertex form because you have that square of a binomial. That's really the key there to identifying that vertex form. And then this final one here, there are no parentheses, so this would be an example of standard form. And there are no examples of intercept or factored form on this page right now. Okay, so now moving down 5 through 12, we're just going to review what we've been doing the last couple days. And all it wants us to do here is identify the vertex. And since they're all in vertex form, the vertex, remember, is just the h and the k. Remember, and we can scroll back here to take a peek at our equation again. When we're using this vertex form, remember the h, you always have to do the opposite sign of what you see there. And the k, you keep the sign that you see. So the vertex for number 5 would be positive 7 and negative 1 because the h is 7 and the k is negative 1. For number 6, the h this time would be negative 2 and the k would be negative 5. So that vertex would be negative 2, negative 5. Now, number 7, the h is 3, and there is no k there, which means it's 0. So this vertex would be 3, 0. Number 8, our h is positive 2. Our k is positive 4, making that point 2, 4. For number 9, our h is negative 1. Our k is negative 3, so that point is negative 1, negative 3. H for number 10 would be negative 4. K is going to be 0 because we do not have a k there, so that vertex would be negative 4, 0. Number 11, our h is positive 5. Our k is positive 1, so our vertex would be 5, 1. And number 12, our h is negative 6. Our k is negative 10, and that point would be negative 10. Oh, sorry, negative 6, negative 10 for the vertex. Okay, we are going to skip over numbers 13 through 15. We're going to get to that next week because we haven't done graphing in standard form yet. So I'm going to wait till next week to get into that a little bit. So we're just going to go back down to number 16, and we're going to review the graphing. So given a quadratic equation in vertex form, find the vertex. Make sure you're doing all these pieces. Find the vertex, the axis of symmetry, tell whether the graph opens up or down. Is it the vertex a minimum or a maximum? And also, what is the y-intercept? And then obviously we're going to graph it. Okay, so first things I'm going to do is identify the A, the H, and the K since it's in vertex form. So the A of this equation here, number 16, is negative 2. The H is also negative 2 because the H, you switch the sign of what you see, and the K, you keep it, so it's positive 4. So that would make our vertex, the H and the K, negative 2 and positive 4. The axis of symmetry, remember, it's not a number, it's an equation, so it will be x equals negative 2. Now, since our A value is negative 2, that means this is going to open down, right? And that means our vertex is going to be a maximum. So what is that maximum or minimum value? Well, it's just your vertex, right? So this is where we're going to talk about the domain and range for a minute. So your domain is all real numbers, right? But your range, the y's would have to be all less than or equal to 4, and that's our range. So that 4 is the maximum value on the parabola. And then your y-intercept is 0, what? So if you substitute a 0 in, what do you get for that y value? So you could just substitute the 0 in for x right here. Then you have 2 squared, which is 4. 4 times negative 2 is negative 8. Negative 8 plus 4 is negative 4. Now, when we go to graph this, we're starting with that vertex, that negative 2, positive 4. We're going to use that axis of symmetry, which is that vertical line. And now we can use that graphing pattern I showed you yesterday to get a couple more points. Another option is you could just find a point like we did here, 0, negative 4. And if you plot that and then you plot one on the other side of the axis of symmetry, you can get your parabola that way. If you want to use the graphing pattern I showed you yesterday, then your A value here is negative 2. So if you multiply negative 2 times 1, 3, and 5, you get negative 2, negative 6, and negative 10. So from that initial point, I would have gone down 2 over 1. Then I would have gone down 1, 2, 3, 4, 5, 6 over 1. I would have ended up where I have that point. And then just do the symmetrical points on the other side of the axis of symmetry. So there's a few ways you can get those points. You can pick a number and plug it in for x and then get the y, which is what we did to find that y-intercept, or you can use that graphing pattern. Okay, so let's go to number 17. Okay, same idea. First thing I'm going to start out with is finding my A, which there's nothing there, which means it's a positive 1. My h, which is the opposite sign, so x minus 3, so it's 3. and k, I'm going to keep that sign, so it's a positive 2. So my vertex is the h and the k, so 3 and 2. My axis of symmetry is always x equals, and it's whatever that h value is, so x equals 3. Since my a is a positive, this is going to open up, and whenever a parabola opens up, the vertex is a minimum. Now in this case, all the y values have to be greater than or equal to 2. And the y-intercept is the point where it crosses the y-axis, which always has an x value of 0. So if you plug that 0 in there, you get negative 3 squared, which is 9, and 9 plus 2 is 11. So now when we go to graph this, I can go 3, 2, which is my vertex. Axis of symmetry going through that point. Now I already found the y-intercept, which is 0, 11, which is up here. So I could just go 3 boxes on this side as well. But if I want to use my little graphing pattern there to get a couple other points, since it's just an a value of positive 1, it's not going to change the 1, 3, and 5. So from my vertex, I'm going to go up 1 over 1. Then I would go up 3 over 1, and then I would go up 1, 2, 3, 4, 5 over 1, which puts me right at those intercept points that I did. And then I'm going to do the same points on the opposite side of the axis of symmetry, making sure it's like a reflection. And there's my parabola. All right, and then let's take a look at number 18. So number 18, my a value this time is negative 1/5. My h is positive 5, and my k is negative 2. So my vertex will be 5, negative 2, and my axis of symmetry will be x equals 5. My a value is negative, which means this is going to open down, and when the parabola opens down, it has a, maximum. Fix that there. Okay, so if it's at a maximum, that means all the y values have to be less than or equal to that value of negative 2. The y-intercept is what you get when you plug the 0 in for x. So if I plug a 0 in here, negative 5 squared is positive 25. Positive 25 times negative 1/5 will be negative 5, and negative 5 minus 2 is negative 7. So we're going to start out by graphing our vertex, which is 5, negative 2. Axis of symmetry. Now you can use the 0, negative 7 as a point on one side, and then 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and just plot the other one on the other side of the axis of symmetry. Or if you'd like, you can use the graphing pattern. Now this one's going to be a little trickier because it's a fraction. So negative 1/5 times 1 would be negative 1/5. Negative 1/5 times 3 would be negative 3/5. And negative 1/5 times 5 would be negative 1. So I would actually have to go down a fifth over 1, then down 3/5 over 1, and then down 1 over 1. So you can see those are a little bit hard to graph. So in this situation, it might be easier to just use the y-intercept and then just do the mirror image of that. That's why there's a couple options for getting more points. Okay, and then number 19, last one. So the a value is positive 1, since we don't see anything in front of the parentheses. The h is positive 2, and this time our k is 0 because we do not see a k value. Our vertex is going to be the h and the k, so 2, 0. Our axis of symmetry is x equals 2. This has a positive a value, so it's going to open up, which means it's going to have a minimum. The range is all the y values are going to be greater than or equal to that minimum, which is 0. And my y-intercept is what I get when I put the 0 in for x. So when I put a 0 in for x, I have negative 2 squared, which is positive 4. So starting out this graph with the vertex of 2, 0, my axis of symmetry, and then you can either plot the 0, 4, and then just do the point on the other side of the axis of symmetry, so look like that. Or, sorry, it's a little crooked. Or if you wanted to do the graphing pattern, 1 times 1, 3, 5, you're just going to get 1, 3, and 5. So I would go up 1 over 1, up 3 over 1, up 1, 2, 3, 4, 5 over 1. So you can see my graph's a little crooked here. And on the other side, you would just match up those points there. So it looks like that. And that's pretty much everything that we've covered as far as graphing in vertex form, finding the intercept, the axis of symmetry, minimum, maximum, y-intercepts, graphing pattern, or just using a table. The only other thing that we did a little bit yesterday was we worked backwards the last 2 days, I think, where you had a graph and you were able to write the equation. So that'll be in the review when we do the review Monday. So that's pretty much everything for graphing in vertex form. Monday, we will review that and then have a little quiz on that on Tuesday. And if you have any questions, please check into one of our meetups on today at 10:30 or Monday at 10:30. Thanks, and have a great weekend.